Welcome to the Relax channel. So whenever I show this Dalai Lama quote, know the rules well so that you can break them effectively, I really meant. So even in this episode, I'm going to show the same. Probably you must have seen. So this is something when you learn about networking, they teach you about the OSI layers, but it is not any hardcore rule that it should be in the same order and it will always follow the same type of a structure. So you may not understand what I meant by that if you are a beginner, because you must have learnt in your college that 7 layers and you will have some type of typical understanding about the same. However, there are instances in the real world, okay, things do change, and when you do some type of tunneling and some type of MPLS or some type of tunneling, things will change, and I can show you the proof how things are different in the real world situation. So you go here and generally you do a wiki page search or something like that, OSI model, something like that, and you can say that you have all these layers, and you can read about the same. Probably you must have read about the same in your college as well as part of their networking subjects when they cover about the same. So I have done extensive video episodes on various topics on network protocols. You can see here networking protocols. I started from basics all the way to high level topics like protocol architecture, and as well as protocol architecture in various levels. It is layer 2, layer 3 and stuff like that. So quite extensively I have done the same, and even in this episode I may put within the same playlist of the YouTube. So you can see here I started with the intro, and down the lane I have also discussed about the OSI model and stuff like that. So which is also the reason I mentioned about the theory versus reality and stuff. Moving on, you can see here after that I have discussed about the stack design architecture, and then protocol RFCs and the protocol headers and fields and stuff like that. So when you come all the way, I have even discussed a way that how you can create your own custom protocol, and how a protocol is designed, how a parser is written, how you can build packets and send packets from parser to the raw bytes, and as well as a packet when you receive the raw bytes, how you can convert into a data structure, and then you parse that and take any decision like an FSM and stuff. So you can go through the same. OSI layers, this is not an episode I want to discuss about any intro of the OSI layer. So let's take this standard OSI layers as an example. So we can take any picture like this. So you must have read about layer 2, which is data link layer, layer 3 and layer 4 transport, and below that you have the network layer, and then you have all this session presentation, and then finally the application layer. So when I was discussing about OSI layers, I have also mentioned that generally when you capture in Wireshark, you may find after the TCP or UDP header, you will directly find the application layer, and sometimes cases like ARC packets, you may find directly an app like stuff directly onto the an L2 situation. And same way, if you see the ICMP packets, you have this IPv4 header or v6 header, and on top of it you may find ICMP packets entire ICMP protocol header. So this is how it is. It changes based on the protocol you use and stuff. But having said that, if you refer this model, you have this network layer and then the transport layer, and you can see the example like in the case of transport layer, you have this TCP UDP and then session and then presentation, and then you have this application layer. So this is how the flow happens, but provided this is not the hardcore way always it happens. In the real world, anything is possible. When you do any tunneling, it can actually break the rules. Okay, so one such example I can show you live here. I was going through some sample packets of this Wireshark. You can find various sample packets. So this is a nice repository. People generally contribute, and they may list it over here. And in case if you have any interesting examples, you can even contribute to them, and effectively they may get categorized and they may list it over here. And trust me, there are also companies who capture a lot of sample packets, and they in fact sell that captured packets to other companies. And we literally stumbled across a couple of such firms, and one even in Bangalore. They have extensive repository of captured packets, and they sell it to various firms. It can be some testing protocol development and testing firms. They can do some type of interoperability tests, and they check that whether it matches that compliance and other stuff, and also the RFC and other stuff. So there is a sort of ecosystem, business ecosystem available around it. So here you can get the similar stuff but free of cost. Okay, so stuff like that. And sometimes when they have that repository captured by a company, sometimes it can have GBs and GBs of data. It can have literally millions and millions of packets. So which is why it's a complete different ecosystem. It is done professionally, and each case is handled, each case is captured, and then they sell that. Okay, so if you are very new to career, if you are new to career, these are things which exists in the industry. Okay, so that's what. So yeah, I was searching for some type of tunneling packets, which is when I stumbled across this IP, and trust me, I was into Wheaton tunneling and stuff. In the case of Wheaton, it does through TunTap interfaces, it does some type of tunneling via UDP, and you can even compress that tunnel. You can even, it works like a VPN. You can compress, you can encrypt, you can do many things. So if you're if you are an admin or network expert, maybe you may already know that. So this is what it happens. And in case if you're a beginner, you are a developer, or else you are just come out of college and you are new to the industry, maybe these things are new to you. So this is quite common. In case of VPN, it does multiple layers of tunneling. Sometimes they do tunneling of IP within TCP, IP within UDP, or TCP within UDP. For example, I have done some type of stack for a customer long back, around 2015. He needs all the packets to be sent not like TCP, it should be sent like UDP, so that you get faster accelerated performance. For some reason, see, I can't disclose extensively because I have signed the NDA, but to an extent I can share the overall aspect. So in general, there are advantages using an UDP packets, and you don't think about UDP is not say for UDP is not protected like a TCP and stuff. See, there are workarounds, and experts as they use in the industry, we know exactly where is what can be patched up. And in the case of quick protocols which Google uses for Google Chrome, you don't use any more TCP for that. They generally communicate with their Google servers using quick protocol which runs on UDP, and they have pushed a lot of transport level logic to the upper layers like application layer. So application layer of quick protocol does the layer 4 operation of what to be done. For example, in the case of TCP, you send ACK packets and other stuff. So that type of session level information is pulled all the way to application layer, and it no longer does in the transport layer. So this gives a superior performance, and they can do so many things in the user space context rather than putting a burden on the Linux kernel space in general. So kernel is not good at handling certain aspects no matter which operating system you use. It's not a question of whether which operating system is superior, Linux, FreeBSD or Windows, whatever it is. It's all about an architectural decision, how you fine tune and how you make this stuff ready for upcoming modern platform. So one such attempt is Google's quick protocol. So that way I was doing some study, and I stumbled across this interesting example so that we can discuss in this episode. So before even discussing that, I need to bring you all the way from your existing context about what you know, especially if you are a beginner, to this situation, so that you get some type of big picture about things happening in the industry, which is also the reason in general I cover extensively. I take my own time and then I cover things in my own sweet time. So don't expect my videos to be cut short, just 5-10 videos of briefing it out or something. So I generally take my own time so that you get that complete big picture and no more sort of narrow-minded approach, just taking this situation and then forgetting about the entire big picture. So which is why I take my own sweet time, so that I can bring you to my wavelength first and then we can go into the topic later. So hop on to this example, IP in IP. So we do a download and you can see here it downloads this cap file or pcap file, whatever name you call. We can directly open in Wireshark. In this case, you can see there is a test packets. It's like a ping request reply. But the interesting thing is these are not an ordinary ping packets. Okay, so if you go here and see here, it is an Ethernet header. After that, you have dual V4 header. Okay, you have a dual V4 header. You have an IP in IP. So here itself, you can see here, you plot it on to the OSI model. You have actually dual layer 3 headers. After that you have the L4, and in this case, since it is a ping packet, we can consider this ICMP like some kind of session or application layer. So some people get confused extensively about this session layer and presentation layer and all that garbage. You can imagine sometimes, so just ignore that. Imagine always after the transport layer, your application layer comes. Okay, so don't sit with that assumption. It is enough if you know those things when you are in college to write the exams and sometimes even your CCMP classes. So because being myself a CCNA, so these things are required for the exam, but once you come out and deal with practical systems, forget about all that crappy stuff. What you learn about this presentation and session, you can see that is like an implicit layer. Sometimes you encrypt the data, you can call, like they mention, some type of encryption, some type of compression, you can call as presentation layer. So it is, no one cares. Okay, just imagine after the transport layer is application layer. So welcome to the real world. Okay, so that way you go here. If you see the ICMP is like on top of this IPv4, but in this case you have this dual v4 protocol headers. So to distinguish, you can see the protocol field, unlike 6 or 17 in the case of TCP or 11 in hexadecimal for UDP. So 6 is TCP, of course, 17 is UDP, and in hexadecimal 11 it is. So something like that. So unlike 6 or 17 or 11, in this case you can see here it has this protocol identifier, or this field value is 4, which tells there is an additional IPv4 header. So you can see after this there is another v4 header, and within that you have this protocol field as 1, which is nothing but ICMP header. After this v4 header. So this way it is a IP within an IP, and in this situation it is sending this ICMP packet. So there itself we are breaking the rules of standard OSI model. So in a way we are not yet breaking the rules, but in a way don't be too much carried away with that OSI model, and don't forget about seeing that big picture. So that is the intent of this actual episode itself. Okay, so moving on, we can take a couple of more examples. We can go here, Packet Life. So this is, by the way, this is another website. You will get tons and tons of information. If you are doing any dynamic routing protocols, you need some sample captures. If you are doing some type of research with network protocols, see, I got several students, especially some are other than, of course, my work as a consultant for companies. I got several students in that. Some are doing their PhD and their what you call as postgraduate, I think doctorate or something. I got some students who are doing that, but they are very much into some research stuff, and they get struck with some research and then they seek my assistance. So that's when I need to sort of guide them. I don't say that I train them. Instead, I need to use the word as I guide them. So these are the things which although they do PhD or after their masters, whatever the higher level degree they do, the problem is they are stuck with that traditional educational model, whereas they may not be exposed to the real world elements. So this is where I need to give them some type of big picture, so that they see the up to date happenings in the industry, and then they get sometimes updated. It depends, some are updated already, some may not be, it depends. So it is quite useful if you are into some type of network research. Packet Life is quite an interesting site. Okay. Similarly, you can find here below that there is a situation, you have this V6 in IP. So we open this and we see what's the deal about. Okay. So you can see here, it's an interesting situation. You have V6 header within an IPv4 header. So in this case, it is again layer 3, dual layer 3. After layer 2, like in this case, it is Ethernet header. So first is your Ethernet header of that frame. Inside there is a packet, and you can see here in this case the protocol field as this identifier as 41, or in hexadecimal 29. You can see here in the raw bytes it is mentioned as 21. So in this example, it is doing some type of tunneling of V4 standard V4 packets, which has its own transport layer, and it can be, in this example they have provided ICMP, but you can imagine this can be TCP, this can be UDP, SATP, anything actually. So you have a standard V4 packet. So above the V4 it is all normal. You can see here above this V6. In this example, of course, it is V6. Above this V6, it is everything is common. It's normal, and in this case, it is an ICMP on that V6, and ICMP, since it is for V6, it's a ICMP V6 version. Okay, so I mean meant for V6. Okay, so because it has to ask ICMP this thing. Okay, so it is a V6 variant of the same. So you can see here it is a V6 variant. So it is not the regular ICMP which has this identifier or protocol identifier as 1. So in this case it is 58 in decimal and 3A or something in hexadecimal. You can see in raw bytes. Okay, so that's what. So you can see the entire stuff is encapsulated within this V4 header. And here to identify that it is a sort of like IP within IP, in this case a V6 within V4, they are using this identifier as 41. So you must have seen the earlier Wireshark capture, it is using this identifier as protocol as just 4. So this is how it is. So if it is 4, it is V4 within V4, and if it is in this case 41, it is V6 within this V4, and you can do vice versa. You can send in V6 you can send V4, and in V6 you can send dual UDP, and in V4 you can send dual UDP, and in V6 you can send dual UDP or dual TCP. You can do any sort of combination. So if you are a beginner, okay, just get this big picture. You have things happening like what they mentioned about the OSI model, but in the real world you can break the rules, or you can even bundle the entire stuff within the application layer. You can even parcel it within the application layer. So you may have extra layers like of course layer 2, layer 3, layer 4, and within the layer 4, let's assume you have UDP or TCP, and within that it may carry standard regular V4 IPv4 packets within that. So you can have entire thing. It's called as transport layer tunneling or something like that. So yeah, these things are possible whenever you do some type of VPN links and any type of SD-WAN and things like that. Okay, so that's what. So we just move on and we see any other couple of interesting examples. Okay, so let's see what this is all about. IPSec. This is a standard. Yeah, it's a standard VPN stuff you will encounter. Okay, in this case you can see the type is, protocol type is, yeah, authentication header 51. You should always understand when you are beginning with this sort of a study, whenever you see a v4 header, first to see what is its protocol is, okay, and then you will get some idea that this is not a standard packet. It may be not a TCP and not a UDP, so this is something else, and then from there you will get some type of picture. So see the protocol header, okay, or the protocol field, and you can decide what could be its upcoming header. So in this case it is 51, which is 33 in hex, and you can see after that you don't have TCP, no UDP, no nonsense. In this case it is an authentication header. It's a different header, and within the authentication header you have some type of encapsulating security payload, which means it is something which is encrypted or something which is bundled. Moreover, I'm not any specialist in IPSec stuff, so if I do any mistakes here, maybe I'm wrong, okay. So but anyway, provided, you can see here it is not any standard v6 TCP or UDP packet. So this is again, if you are not aware, this is again something new for you, and you don't have stuff like a protocol, TCP source port, destination port, and all this regular stuff, okay. In this case you don't have anything like that. So once again, it is something new in case if you are starting, and it is also not that standard stuff what you expect seeing that OSI model or something, okay. So sometimes you should understand within this it can put an entire packet, entire valid v4 packet within that after that auth header or something. So it can even bundle that, but I feel this is something to do with just authentication, not about any carrier or transport packet or something. I'm not sure, so that's why I'm just mentioning the same. So it is again repeating, so there is nothing different in other packets. So we close this down and we can explore the other set of examples before we conclude this episode, okay. So that way, if you go here, there is something like IP across ICMP across .1q. This is something I believe long back I worked on 802.1q. I am almost forgotten. Yeah, in this case, you can see here, you don't have, after the Ethernet header, you don't have direct ICMP, IPv4, packet. So in this case, there is this extra layer 802.1q, and within that you have this IPv4 header, and within the IPv4 you have the standard ICMP, stuff, okay. So I can't call header because it can have anything within that. So ICMP part, you can carry any test data, so we can't call it as header. It is not something like that. It can carry any payload. So you can see here it carries this payload. You can put ABCD, you can put 1 2 3 4, you can put all zeros over there, you can put any sort of combo strings over there, you can put even repeating hello worlds in that. So which is why I can't call just like that as a header. It is like an sort of like an application layer protocol, okay. So this is a different example, and we can open this GRE. So GRE stands for, you can see here, generic routing encapsulation. So that itself hints you that it is once again doing some type of magic, okay. So you open here and you see here you have this Ethernet header, and here it hints 0800, which means after the Ethernet header you have this IPv4 header. So likewise you can find IPv4 header, and within the IPv4 header, after that you don't have again regular TCP UDP, so you get this GRE. So you can see here, first go to the protocol field. You can see here it is hinting that it has this GRE set. That byte is set as GRE 47, and in hex it is 2F, and then you have this GRE encapsulation header. You can see here it has this flags and other stuff, and in that it again tells what the GRE is carrying. So in that it tells again it is carrying a v4 packet. So again it is 0800, and within that again you find this standard v4, and then you have this standard stuff. So in all these examples they have put ICMP. So any place if you find this ICMP, imagine this can be a TCP UDP, or you may have an entire encapsulation within that. Once again it may have entire v4 and then TCP UDP, everything. So which is why I'm saying this is really confusing. Okay, if you're new to the same, don't go too serious about this model. In case if you have questions asked in the college, just spit it out. Whatever you read, you need to pass, so just do it. I got students from India as well as abroad. Even in abroad, it's the same thing. When you are in the college, they expect you to write all this theories. Just for the sake of marks, you need to pass end of the day. So for that sake, just read it and vomit whatever it is possible so that you pass in that exam. But in the real case, it is not strictly the same case. You can break the rules. You can do any levels of encapsulation. Sometimes you may have some type of Tor networks that can even do some levels of encapsulation. So anything is possible in the real world. Okay, so don't be too much concerned about all these useless theories. It is required when you are new to learning something, so you need to learn. But once you are a master, just follow what Dalai Lama says. So you can break the rules. To break the rules, first you need to know the rules. To be a thief, first you need to know how the security stuff works, and then you can think about how you can steal something. Okay. And I forgot to mention something. Sometimes you can encapsulate an entire layer to frames within an IPv4 packet as well. You can send this entire frames as UDP packets encapsulated within an IP header packet on standard Ethernet. Sometimes you can also put this on a TCP session and send it across. So you can do a lot of tricks, and as a beginner you will be confused why all these things happen. So it all depends on business use case. Sometimes they may need some type of LAN across internet. You can build a LAN across internet. So that's what is SD-WAN, if you are not aware of. So sometimes they may do that, and sometimes they do without a layer 2 aspect. Sometimes they do with layer 2 aspect. In that case, you need something like, if you pick this, picture, you can put this entire layer to this data link layer all the way up. Entire stuff you can put as an application layer stuff, and then you can bundle it, and then you can send it across. And industry makes money out of such technologies when it really requires, and so that you get seamless, network connectivity. So one such use case is like you can have a home network, you can have a office network. You need to connect these two networks in you need to extend this home network and that office network, and with some type of stuff. VPN is one example, but some type of tunneling. You want to connect this LAN in the home and the office LAN in a way so that you can connect all the systems in the home network to the office systems, and then you can work seamlessly. And sometimes if it is some enterprise, they want to connect one branch with the other branch, and they may do some type of tunneling. Sometimes they do for connectivity alone, sometimes they do for both connectivity as well as security. So they may do in multiple layers. Sometimes they do a simple VPN. Sometimes these things the company may not do, but they buy a service from some type of SD-WAN provider. The SD-WAN provider may do this stuff. So in that case, they may do that bundling based on their SD-WAN infrastructure, and you may be just a customer of that vendor technology. So you just link all your enterprise or office or home, whatever it is, to that device, whatever the SD-WAN guy provides, and from there it gets tunneled across. He may have his own path. He can send whichever way he wants. At some cases he may route this packet. Some cases he may push through layer 2 circuits. Whichever thing is put across in his deployment, he may do the same. So these things are very much common in the industry. So people who are still working as well, they are not everyone is well aware of these things, but these things are the things which drives the current networking technologies across the world. So any such combinations are possible. Sometimes, as I said, sometimes it's just connectivity, but sometimes it is also to do with the security and some type of seamless connectivity. Okay, so that's what. So such things are possible with simple VPN technologies. You can have OpenSSH or something like that, or I mean to say OpenSSL, not OpenSSH, OpenSSL or something. Sometimes it can be possible with Wheaton, or sometimes you may need to do something Wheaton you can put on top of something else, and then you can do multi-level tunneling, and then you can send it across. Sometimes it may be a reason you need to maintain the anonymity, so they may do the same. Sometimes it is just to do with security plus anonymity, and any such combinations are possible. Okay, I'm just giving all that big picture as much as possible so that you will get that whole idea. So with this, I would like to conclude this episode. Like I mentioned, the Linux channel, I would like to cover about very unique topics. I don't want to cover about something which everyone takes or everyone discusses. So with that, I want to keep that scope completely unique. It should be part like journalism. It should be part very educational, but it is not always educational as well. I can suddenly take some other topic as well, something which is quite interesting, catches my attention. I may cover about that, and sometimes from there I can hop on to something about completely a different technology which again catches my attention. So this is what it keeps this channel unique, I feel, rather than going in a sort of predeterministic path. And this may help several viewers. Some may be interested in networking, some may be interested in storage, some are interested in kernel development. So this may help any newcomers in the industry. They may be still confused about the networking stuff, but there's a lot to learn, stuff like that. There is no rules. You can break the rules whichever way you want, and there are certain reasons why you need to break the rules. So if you have anything to discuss, be in touch via mail or discuss via YouTube comments. I have recently enabled the YouTube comments, but I may heavily do some type of moderation. I'm not interested leaving any comments which may distract the topic here and there, anything about racism and stuff like that. I may heavily moderate the same, but I'm going to keep any such interesting comments which is more to do with Q&A, and it may help other viewers as well. Okay, so that's about it. So anyway, if you like this video, hit the like button, and if you want more and more videos like this, you can share your feedback about the same. So thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.